So we'll start with the calculator and then we can move on to StatCrunch. So our objective is to determine if there is a difference in developing flu between cell-derived and egg-derived vaccines. This is a test for homogeneity, but do keep in mind, regardless of whether it is a test for independence or test for homogeneity, you're doing the same thing, right? It's in terms of interpretation. A test for homogeneity comes in medicine. Well, clearly, you know, it's a medicine example, medical example. Now, could we use the chi-square test, regular chi-square test, for a goodness of fit example? Do you follow my question? Could we take a goodness of fit example and use the regular chi-square test, the one that you use today? No. No. Goodness of fit test is different from a chi-square test that we have here. So do it using the calculator. So what should we do? The very first step would be to enter the data in our matrix. So matrix 1, A, will contain our observed frequencies, and in our case, it is 2 by 2. And every single cell count is over 5, so reasonable, so 26. 3,874, 24, 3,876. Here is a question. Even before we proceed with the test, do you think that there is some sort of a connection between the two? That depending on the type of vaccine that you got, the chances of you developing the flu, does it change? Take a guess. No, why not? It's almost the same as you move from cell-derived to egg-derived. So I enter the observed count, so second mode to exit, press start, over to test, scroll down, and is it C or D? D. C. Enter and enter. That is the value we get. Chi-squared is 0.0805. The p-value is 0.7765. The degrees of freedom is 1. Let's see. Can you formulate in words? I mean, of course, semantics is going to differ, but a reasonable hypothesis. If you have to explain this to someone else, what would your null and your alternative be? Talking about. So a good way to say this would be null. There is no difference in developing flu based on the type of vaccine. The alternative will be there is a difference. Well, the p-value is 0.7765. So should we reject the null? No. we do not reject the null. Which would mean there is no difference on whether you use a cell-derived vaccine or an egg-derived vaccine. It doesn't affect the chances of you getting flu or developing flu. If you said, ignore whatever the calculator gave me, I don't care, I'll reject the null and conclude there is a difference, the probability that you would be making an error, a type 1 error, based on the data that you have is 1%. 100%.
Oh.
Who said that? What's your name?
Ava.
Ava, that is correct. 77.65%. If I ignored this test result and I said, oh no, there is definitely a difference in you developing flu depending on the type of vaccine, the probability that I'd be making a mistake is 77.65%. So should you make a conclusion knowing that you could be wrong with a probability of 77.65%? No, that does not make you smart. So we do not reject null. In practice, I would stop right here because I found no connection between the two. There is no need for me to go any further. The only time we proceed with relative risk and odds ratio and stuff is to determine effect size. But since we did not reject the null, I can stop right here. But there is a reason as to why the book wants you to do this, and we will go over that in a second. So row labels, I'll just go with cell, egg, colon, yes, no. The row variable is type of vaccine. Column variable developed flu or not. We have to enter the values. So what is it? 26, 3,874, 24, 3,876. Compute. That's what we get. Good. So it's a large p-value and chi-square is extremely small. So do we conclude that there is no significance in terms of there being a difference? Yes, we can say that there is no difference at all, and the answers match up. Right. On an exam, you just have to interpret what's provided to you. Okay. So we want to find relative risk of developing the flu. So I will call P1 to be the probability of developing flu. P2, the complement of that. Not developing flu. So last time I made it very clear that we can't simply look at the probabilities, rather we have to look at the conditional probabilities. So we have two cases. we can condition on type equals cell. I'll call it 1, 1. Develop. Given A. Likewise, I need 2 of them here. 2, 1, type equals cell. 2, 2, you develop flu, type is A. Right, we are looking at probabilities. So put PR to indicate probability. So we want to determine if we develop flu or not. So in this case, we want to condition on yes, that we develop flu. So what is the probability of developing flu, which would be 1, 1, given the type is cell? You can tell me. We did this last time. Conditioned on the vaccine being cell-derived, what is the probability that you develop flu? The table is up there. 26. Well, that is the count. I want the probability. So it is 26 divided by what? 3,900. Why not 7,800? Huh? Because we are conditioning on vaccine that is cell-derived. And what is that probability?
0.0066.
Okay. The second case, you develop flu conditioned on the fact that the vaccine is egg-derived. How do we find that probability?
24 divided
24 divided by
by 3,900.
3,900, and what is that?
0.006. 1, 5.
6 1. Relative risk is simply the ratio of the two. So (0.0066) divided by 0.0061. What do we get? .99 something or 0.98.
1 point.
Ah, okay, 1.08.
0.08.
And what did we mention last time? If the relative risk is close to 1 or equal to 1, then there is no difference at all. Yes, in this case, it is equal to 1, but there is no difference between the cell-derived vaccine group and the egg-derived vaccine group. Does that make sense? So they are one and the same. How about the Oats ratio? The Oats ratio will simply find the odds of the first group, which is you develop flu, given that the vaccine is cell-derived, and divide that by P12 over 1 minus P12. Make sure you put parentheses properly. Put it in the calculator and tell me what you get for the Oats ratio. So when you plug in the values, all we have to do is take these probabilities, plug it in there. Numerator would be 0.0066. 1 minus that value would be 0.9934 divided by 0.0061 divided by 1 minus that 0.9939. And if you plug that in, you get 1.06. And as I mentioned last time, if the odds ratio is close to 1, then there is no difference between the two. Good.